Okay, part 2, video, this is 4.1 notes, part 2. If you change the number of protons, you get a different element. So changing the number of protons, changing the number of protons means that you get a different element. So in other words, hydrogen always has one proton and helium always has two. If I add another proton to hydrogen, I get helium. Or if I add one more proton to helium, I get lithium. Elements are arranged on the periodic table in order of their atomic numbers. Numbers. So now would be a good time to show you what these atomic numbers look like here. Here's a periodic table, and oftentimes you'll see this 5. It'll be written, for example, it might be right over the top here. Okay, it might look like that. Okay, so anyway, the point is these elements are arranged by atomic number, and what this atomic number tells you is the number of protons in the nucleus, always. So this number 7 always represents nitrogen. It never ever represents silicon. 7 is unique to and connected to nitrogen, just like 8 is unique to and connected to oxygen. Again, what does this number represent? The number of protons in the nucleus. If you change the number of neutrons in an atom, you get an isotope of that element. Yeah, if you change the number of neutrons, you get an isotope of that element. And the number of neutrons can be seen down here in the mass, atomic mass of the element. Okay, that's the number of protons and neutrons combined in the atomic mass, and we're going to get to that in a minute. If you change the number of electrons in an atom, you get blank of that element, and that's called an ion. In a neutral atom, the number of protons equals the number of electrons. Okay, now oftentimes atoms are not neutral. Oftentimes atoms have a charge. In other words, they are ions mostly. Okay, the charge of an ion is found by, how do I figure out the charge of an ion? I can take the number of protons minus the number of electrons. Taking the number of protons minus number of electrons. Removing electrons of an atom results in a positively charged atom. Positively charged ion, or something called a cation. Positively charged ion or a cation. Okay, I'm going to demonstrate below here. Let's say, for example, we have, well, let's take lithium, number 3 on the periodic table. Okay, lithium. That's number 3, and it's got an atomic mass of 6.9. Okay, so if I wanted to draw a model of lithium, it's going to look like this. 1, 2, 3 protons. Okay, those are little plus signs that I put in there. And 6.9, I'm going to round up to 7. These guys are going to be neutrons. So 3 minus 7, that means there's going to be 4 neutrons there. Okay, 3 protons, 1, 2, 3. This number here is protons and neutrons. That tells us our mass, right? I've got 3 protons, 4 neutrons, for a grand total of 7. I rounded 6.9 up. Okay, how many electrons do I have? Well, if it's a neutral atom, like we just said here, if it's a neutral atom, then it's going to have protons equals electrons. So let me draw 3 electrons. 1, 2, and 3. Okay? What about if I had this right here? What if I had the same thing, lithium 6.9, but it's got a plus charge on it? Well, I do the same thing here. I draw 3 protons. 1, 2, 3 protons. That never changes, right? Again, I've got 7 total. I'm going to round that up to 7. Let's just round that up to 7.0. Let's round that up to 7. So now I've got to draw in 4 neutrons. 1, 2, 3, 4, 5, 6, 7. That's what that number is. Okay, now I've got a charge here. I've got a plus charge. So each electron has a -1 charge. I've got plus 3. Each electron has a negative charge, so now I've got plus 2. I just added an electron. Plus 1. Okay, this electron cancels out that neutron. I'm sorry, that proton. This electron cancels that proton. That leaves me with 1 proton that does not have a connected electron to it. So that's what my Li plus is going to look like. Well, let's do the same thing with a negative charge. Let's do the same thing here with a negative charge like that. Okay, here's how that'll look. Again, you start out by drawing your 3 protons. That never changes. How many neutrons does it have? Well, there's 7 total. That's my mass total. 7 particles total. So I've already got 3 accounted for, so that means I must have 4 left. That adds up to 7. That's what this number is. One more time. Okay, now I've got a negative charge. So each electron has a -1 charge. That -1 cancels that. So now my charge went from 3 to 2 to 1. Now it's 0. I've got a 0 charge. Look, each one of these protons and electrons cancels each other out. Okay, this symbol right here now is telling me that I've got a negative charge. So how do I do that? I add 1 more electron. So let's count up all the charges. -1, -2, -3, -4, plus 3. -4 plus 3, that's +1, +2, +3. -4 plus +3 is equal to -1. Okay, so adding electrons to an atom results in a negative charged ion, and these negative ions have a name. They're called anions. All one word, anions. That's going to conclude part 2 of the notes, and I'll move on to the last part, I think.